Now students, let us start with the fifth question, first part of exercise 9.7 based on indefinite integral. Question is cos inverse x dx. As I told you earlier, whenever there is only one function, then we take 1 as the second function. So taking cos inverse x as first function and 1 as second function. Now taking cos inverse x first function and 1 as second function. Now integrate by using isolate first function. Integral of second function is x minus integral of derivative of first. So we can write derivative of cos inverse x is minus 1 upon under root 1 minus x square into x dx, like this. So what we get? X cos inverse x plus integral of x under root 1 minus x square dx. Now students, we know very well that how to integrate this type of integral. So we can write this integral as 1 minus x square its power minus half dx. So putting either we can put 1 minus x square equal to t, or we can put x square. So better will be putting 1 minus x square equal to t. On differentiating, we get minus 2x dx equal to dt, and x dx equal to minus of dt upon 2, like this. So our question becomes x cos inverse x minus of dt upon 2, and this will be t power minus half dt. So after putting, the integral will become like this. Now let us integrate this factor. Minus half plus 1 minus half plus 1 plus c. So what we get? X cos inverse x minus half, and we get over here root t upon half plus c, like this. So we get x cos inverse x minus of root t plus c, and value of t is 1 minus x square. So in place of t we can put 1 minus x square is c. So students, this is the answer. So very simple question. Now let us move to the next part of fifth question, second part. Second part is cot inverse x. So let us do the second part, fifth question, second part. Integral of cot inverse x dx. So moving in the same way, because here also we have only first function, we have only one function cot inverse x. So we will take 1 as second function, and we will take cot inverse as first function and 1 as second function. So first function, integral of 1 is x minus integral of derivative of first into integral of second is x dx. So we know very well that how to integrate this. X upon 1 plus x square dx, like this. So we get x cot inverse x 1 upon 2. Now to integrate this factor, in the denominator we have 1 plus x square, its derivative is 2x. So to make the derivative in the numerator, we multiply and divide by 2x dx. So what we get? X cot inverse x plus 1 upon 2. F dash x upon fx is log fx. So students, this is the answer. So very simple question, students. Then we have tangent root x. Third part is fifth question, third part. Integral of tangent inverse root x dx, like this. So let us do this question. Students, as we solved question number 4th first part sine root x and cos root x, so on those questions we put root x equal to t. So here also we put root x equal to t, x equal to t square, and dx equal to 2t dt, like this. So what we get? We get tangent inverse t, and dx is 2t dt. So in place of dx we write t dt. Now we can take now inverse function as first function and t as second function. Now let us apply the formula. So we can write first function, integral of t is t square upon 2 minus derivative of first 1 upon 1 plus t square into t square upon 2 dt, like this. So on multiplying, what we get? T square into tangent inverse t minus of t square upon t square plus 1 dt, like this. So we get t square into tangent inverse t. Now over here adding 1 and subtracting 1, like this. So we get t square into tangent inverse t. Now separating, we get 1 minus 1 upon t square plus 1 dt, like this. So what we get? T square into tangent inverse t. Now integrating, integral of 1 is t plus, and integral of 1 upon t square plus 1 is tangent inverse t plus c. Now putting the value of t is root x. So root x square is x, tangent inverse root x minus root x, and tangent inverse root x. So students, this is the answer of this question. So I hope this is clear to you, students. The next question is secant inverse root x dx. Now students, moving in the same way, so here also we put root x equal to t. It implies x equal to t square and dx equal to 2t dt. So the question becomes secant inverse t, and in place of dx is 2t dt, like this. So keeping 2 outside, now integrating, first function is secant inverse t is first function, and integral of t is t square upon 2 minus derivative of first 1 upon t under root t square minus 1 into integral of second t square upon 2 dt. So we get 2 secant inverse t into t square upon 2 minus 1 upon 2 t under root of t square minus 1 dt, like this. Now integrating this factor in the same way, so multiplying by 2 first, we get secant square t into t square minus we get t, and we can write this factor as t square minus 1 power minus 2 dt. Now here also we can put, or we can multiply and divide. Here we have two options, either we can put or multiply and divide. 2t t square minus 1 power minus half dt. So what we get? T square secant inverse t minus half. Now this is the function and 2t is the derivative. So what we do? T square minus 1 minus half plus 1 upon minus half plus 1 plus c. Now putting the value of t is root x square is x, secant inverse root x minus half, and this is equal to 2 by 1, and t is x minus 1, this is power half plus c. So answer is x secant inverse x under root x minus 1. So students, writing one more step, x secant inverse root x minus of under root x minus 1 plus c. So students, this is the answer of this question. Now the next question, sixth first part, integral of x sine inverse x. So here one function is algebraic, other is the inverse function. So according to Eilert, taking inverse function as first function and x as second function. So we write first function, integral of x is x square upon 2 minus derivative of first. So derivative of first is 1 upon under root 1 minus x square into integral of second, this is x square upon 2 dx. So we get sine inverse x into x square upon 2 minus 1 upon 2 x square upon under root 1 minus x square dx. Now students, to integrate this factor, so to integrate this factor, we get sine inverse x into x square upon 2 minus 1 upon 2. So to integrate this factor, we put x equal to sine theta and dx equal to cos theta d theta. So we get sine square theta, dx is cos theta, and 1 minus sine square theta d theta. X square upon 2 sine inverse x minus 1 upon 2. So what we get here? We get only sine square theta d theta. Students, keep this type in your mind that whenever we have x square upon under root 1 minus x square, so we have to put sine theta. जब हम चैप्टर करेंगे डिफरेंशियल इक्वेशंस तो उसमें भी ये जरूरत पड़ सकती है. Now students, we know very well that how to integrate sine square. Now to integrate sine square, we write 1 minus cos 2 theta upon 2 d theta. So we get x square upon 2 sine inverse x minus of 1 by 4 like this, and integral of 1 is theta, and integral of cos 2 theta is sine 2 theta upon 2 plus c, like this. Now let us solve it further to match the answer. So x square upon 2 into sine inverse x minus 1 by 4. Now theta is the value of theta is sine inverse x so we get theta is sine inverse x, and formula of sine 2 theta is 2 sine theta cos theta upon 2 plus c, cancel 2 with 2. So we get x square upon 2 into sine inverse x minus 1 by 4 sine inverse x. Value of sine theta is x, and value of cos theta is under root 1 minus x square sine square. So क्या बन जाएगा यहाँ पर? ऐसे आएगा. आई राइट हेयर कि अगर हमने cos थीटा की वैल्यू फाइंड करनी है, cos थीटा इक्वल टू अंडर रूट, यू कैन सी हेयर दैट cos थीटा इज इक्वल टू अंडर रूट 1 minus sine square. So cos theta will be equal to 1 minus x square, like this. So this is the answer, students. Next part is integral of x cot inverse x. Here also taking cot inverse as first function and x as second function. So we write here cot inverse x first function, integral of x is x square upon 2 minus derivative of first minus 1 upon 1 plus x square into integral of second is x square upon 2, like this. So writing it again, we get cot inverse x into x square upon 2 plus 1 upon 2 x square upon x square plus 1 dx, like this. So we get cot inverse x into x square upon 2 plus 1 upon 2. Now here degree is same, either we divide or what we do, adding 1 and minus 1. So we get cot inverse x into x square upon 2 1 upon 2 1 minus 1 upon x square plus 1 dx, x square upon 2 into cot inverse x plus 1 upon 2. Now integral of 1 is x and this is tangent inverse x plus c. So this is the answer. So very simple question, students. Now similarly we can do the next part, x secant inverse x. So now let us do the third part of this question, x secant inverse x dx. So students, moving in the same way, taking secant inverse as first function. Now let us integrate. Taking secant inverse as first function, integral of second function is x square upon 2 minus derivative of first x under root x square minus 1 into x square upon 2 dx. So we get secant inverse x into x square upon 2 minus of keeping 1 upon 2 outside. So we get x dx upon under root x square minus 1, like this. And we know this that how to integrate this factor. ये हमने देखो स्टूडेंट्स बहुत बार किया है, अगेन एंड अगेन. दिस इज see here, to integrate this factor we multiply and divide by 2 and write it like this. Here we get 2x and x square minus 1 its power minus half dx. So this becomes secant inverse x square upon 2 minus 1 by 4. Now after integrating, this will be minus half plus 1 upon minus half plus 1 plus c. So we get secant inverse x square upon 2 minus 1 by 4 into 2 by 1 under root of x square minus 1 plus c. So students, this is the answer, x square upon 2 secant inverse x minus 1 upon 2 under root x square minus 1 plus c. So very simple question, students.